I'm supposed to be getting a new telescope today. Should be arriving any minute. Oh, oh, just a bird. Oh yeah. This is the 8-inch Rowe Ackerman Schmidt Astrograph, or RASA, by Celestron. It has a focal length of 400 millimeters, which we'll be talking about what that means in a later episode.
A box inside another box?
A box inside a box. So here it is, my new telescope, the 8-inch RASA. One of the first things you might notice about this one is that it doesn't have an eyepiece, so you can't use this for visual observation at all. You can only use it for astrophotography. The other thing that's weird is that right here in the back where you would think that the camera would go, there's actually a fan there. So you can't even put the camera in the back. You actually put the camera in the front, which is where all the light comes in at. So this is a very unique telescope and one I look very forward to experimenting with. So let's talk about the elephant in the room. I shaved. I'm a high school teacher, and we're back in the classroom and we're required to wear masks, and the beard with the mask was kind of bugging me and stuff, so I decided to take it off. I've had a beard for a long time, so I think I actually kind of look a little bit weird and I'm a little sensitive about it, so let's just not talk about it anymore. Let's talk about my new telescope. I've got a new telescope. It's a Celestron RASA 8-inch, and I love it. I've only used it just one time, and actually we're going to be editing the first light images from that telescope. So I thought I'd bring you along for the journey. In fact, it's a great time to talk about image editing. When I first was learning how to do astrophotography, this was the one concept that I just did not understand at first, and I had to watch a lot of different YouTube videos and get little pieces of little tricks here and there to be able to put it all together. So I thought I would show you my workflow for editing astrophotography images. So this is actually going to be two pieces. The first step is to stack all the individual images in a program called Deep Sky Stacker. You know, there's other tools out there, but that's the one I use. It's free and it seems to do a really good job. I'm going to create a second video for actually editing the images, and again, you can use a variety of tools for that. The one that I use is Photoshop. So this first video is all about Deep Sky Stacker. Let's go ahead and get into it. Deep Sky Stacker has all these little tools up here which are going to allow us to import our various image files. So you might think, well, what files is there just to import? Just the pictures we took, right? Actually, you'll get the best results if you include some calibration frames with your light images. So when you're taking pictures of your deep sky object, whatever it is, let's say it's a nebula or something, those are called your light frames. But you also want to take dark frames, bias frames, and flats. I'll probably be creating a separate video on how to do calibration frames later, but there's lots of videos out there that can show you how to do that as well. So our first step here in Deep Sky Stacker is to bring in our light frames and all of those calibration frames as well. Now, since this was my first time using this telescope, it actually took me a little while to figure out how things work, and so I got a late start. As a result, I didn't have time to take my flat frames and That's kind of a shame because I really find that the flats make the biggest difference in terms of qualities. But well, you know, it's the first time using this telescope. I have no idea if these pictures are going to come out decently at all. So you're along for the journey. Let's go ahead and bring in our light frames. So here you're going to click on this link up here that says Open Picture Files, and you're going to navigate to the place where you have stored your light frame. So this was Messier Object 16, that's the Eagle Nebula, and you can see that I actually have two folders for my light frames, NB and WB. This is my narrowband and my wideband photos. So what's the difference here? The dedicated astrophotography camera that I use is an ASI 294 MC Pro. This is a color camera, so it already handles the red, green, and blue channels for me. If you had a monochrome camera, you would need to take separate pictures using a red, green, and blue filter. Now, even though this is a color camera, I still use filters for it, primarily for light pollution. I live under Bordeaux 5 skies, which is okay, but I still have some light pollution to contend with. I actually will shoot a lot of my pictures using two different filters. This is the Optolong L Extreme. It's a dual narrowband filter. So what that means is that it blocks out all of the light of the EM spectrum except for the wavelengths that hydrogen alpha emits and O3. I find that the hydrogen alpha primarily shows up as red in my images, and the O3 is real heavy on the green. So I don't really get a lot in the blue channel with my color camera. So to kind of compensate for that a little bit, I also use a wideband filter. This is the IDAS LPS D3. So I don't hear a lot about this filter on the internet, but when I was looking up the spectral charts, it seemed to be good for the types of light I have in my neighborhood, and I have really had really good success with this. This filter lets in pretty much all of the light and only specifically blocks out certain sources of man-made light. So the idea here is that we're going to get all of the colors from space and try and block out the unnatural stuff, and it really does a good job. So the question is, how do I stack images from two different filters? What I like to do is I like to stack all of the pictures for one filter and create an image just for that one. And then I create another stack for my second filter and save that as a totally different file. Then in Photoshop, I sort of merge the two. And in my Photoshop video, I'll show you how I do that. And now, the one thing you want to make sure that you're doing here is that if I am going to be bringing two separate pictures into Photoshop, I want to make sure that all of the stars in both of those images line up. And Deep Sky Stacker has a feature that will help us ensure that our stars do line up during the stacking process. I'll show you how to use that feature now. So we're going to start by bringing in, let's do the narrowband ones first. So I'm going to bring in the one for my L Extreme. These are all of my light frames. I'm just going to highlight all of the files and open those. And you can see all of my light frames are in here now. One thing that I should point out is that you're going to want to go through before you bring your pictures into Deep Sky Stack, you're going to want to go through and check them all out. Make sure that they actually look okay. You don't have weird satellites or airplanes or something shooting through your images. And the way I do that is I just open them up and I scroll through one picture at a time, checking to see are any of them out of focus or is anything funky. And if I do find some funkiness, I just go ahead and delete the bad picture. Now I've already gone through all of these, so I know that all the pictures I just imported should be in pretty good shape. Now I do want to check all of these pictures, so there is a check all option right here. I'll click on that, and that means that all of the pictures that are checked are going to be included in my final stack. Now that I have all of my light frames brought in, now it's time to bring in those calibration frames I was telling you about. I'm going to do the darks first. Now, as I had mentioned, I have already created a calibration library for these types of files. My light frames were 60-second exposures. So let me just mention how cool it is to be able to take a 60-second exposure. My new telescope, the Raza, is an f2 scope. It's extremely fast. That f2 means that it can collect a lot of photons and send those photons to my camera in a very short amount of time. To get the same level of exposure with my old telescope is f10. I'd probably have to shoot at least a 5-minute exposure, maybe even more, to get the same amount of light as this scope can pull in just 60 seconds. It's really crazy. I like it. That's cool. So here, my light frames were 60-second exposures at 120 gain. So I need to make sure that the calibration library I'm using also is set for 60-second exposures at 120 gain. So I'm in the right folder. I'm going to bring all of those dark images in. Now we can tell the difference. There's a little coded icon for each one of these. This one's with the little circle, those are our light frames, and these ones with all the little dots, those are our dark frames. Let's bring in the flat calibration files next. Going to click on those. Going to open up my, oh, you know what? For this one, I actually had forgotten to take flats, so I don't have any flats for this image. So we'll skip that one for now. And instead, let's bring in the bias pictures. Now, I have a library for those as well. And I just need to make sure that the gain is the same. 120 gain is what was in my light frames, so I'm going to use bias frames that also are set at 120 gain. I'm going to import all of those. And just like those other ones had specialty icons, this kind of gray looking icon signifies my bias frames. As I mentioned, I'll do another video later to tell you what those calibration frames are and how to create them. For now, if you don't have calibration frames, it's okay. Deep Sky Stacker will still do a good job of stacking all of your images without them. You can just bring in just your lights. The calibration frames are really going to cut out a lot of the noise and static and other weird nonsense that is just going to mess up our picture. So by including those things, we're going to get a much cleaner image. Now that I have imported all of the files, I need to do one more thing. So I had mentioned that we're going to have two different pictures here, one for my wideband filter and one for my narrowband filter. And in order to make sure that the stars line up, we need to create something called a reference image. What the reference image is it's basically you're telling Deep Sky Stacker, this picture, use this picture as a model for lining up all of the other pictures. And so it can be any picture you want. I'm just going to set it aside and say this is the special one. And all of the stars for all of the other pictures are going to line up to that reference image. You can use a picture from the narrowband filter or from the wideband filter or from any of your other filters if you're using a monochrome camera. I usually like to use a reference image that has like the strongest star signal. And for me, I find that the stars show up a little bit better with my wideband filter. So I'm going to choose one of those as my reference image. Here's how I create that file. I'm going to go into the folder that contains my wideband images. And I'm just going to find a picture. Now I've already gone through here and deleted all the bad ones and stuff, and so let's say that I choose this picture right here. What I'm going to do is copy this image and then just paste it into the same folder it's already in. So here you can see I have a copy. I'm going to rename this file reference image. I like to put it all in capital letters just to make sure that it really stands out. Now the important thing to remember here is that we aren't going to include this image in our stack. We already have this picture. That's why we made a copy of it. This one is just for alignment purposes. So we're going to bring it in, tell Deep Sky Stacker to use it for alignment purposes, but don't actually include it in the stacked image. Now that I have created the copy of that file, I'm just going to open that picture file. So just once again navigate to my a wideband folder this time. Remember, these are all narrowband images I had already loaded, so I'm going into the wideband folder, pulling in my reference image and selecting open, and just make sure that the checkbox for your reference image is not checked. This would create some weird stuff. Since we're stacking narrowband images, it would look really weird if I included one wideband photo in there. So make sure it's unchecked. Now this is important, and the first time I filmed this I had forgotten this step and had to go through and restack them again. So don't forget this. When you bring in your reference file, you have to actually tell Deep Sky Stacker that you're going to use that image as a reference file. So to do that, all you have to do is right click on your reference image and choose Use Reference Frame. All right, so now that all my files are in here, it's time to actually start registering and stacking these. So the next step is to hit this link right here that says Register Checked Pictures. The first thing I like to do is find out how many stars I have. So we're going to go here to the Advanced tab, and we've got this little slider here. And if you click on this button, what it's going to do is it's going to count the stars. And it says I found 156 stars. If this is just an incredibly large number, then what you want to do is you want to drag this up and click the button again, and it will find fewer stars. This is your star detection threshold. So the trick here is that we want to have a lot of stars to align, but not so many that it really slows down the computing process. It's going to take the computer a while to line them all up and rotate things and get everything all matched. And if I'm using a tremendous number of stars for that matching process, it's going to take an extra long time. So how many stars should you set this setting to? It turns out that's kind of a difficult question to answer, and it wasn't until I started playing with my new telescope that I realized that it really depends on the scope you're using and the target that you're shooting. For example, when I would use my SCT here to image a very small target like a galaxy or something, it wouldn't be uncommon for me to only get like 9 to 15 stars. Now that's not very many, but it was more than enough for Deep Sky Stacker to do its job. With when I imaged this target, I was getting close to 1,000 stars, so I turned that number down to 100. I thought, well, if 15 will work, then 100 should be way overkill. But because I was shooting with 2 different filters, and because I had a meridian flip in the middle of this, some of my pictures were upside down, and with 100 stars to choose from, it seemed like Deep Sky Stacker was getting it wrong. It found that it could get some stars to match, which weren't actually the stars it should be matching. So as a result, some of my images, when it stacked, it actually stacked them upside down with regard to one another, and it did not come out right. So in that case, I actually had to turn my star threshold way up to about the maximum number of stars that it could image, and then Deep Sky Stacker was stacking it properly. So the moral of the story is here, you can go for a lower number for speed, but if you're using multiple filters, or if a meridian flip took place, you might need to turn that threshold up. Experimentation is going to be your ultimate answer. We go back to actions here. You can see that I've got a warning. This little yellow message is telling me, hey, you forgot your flat frames. Like I mentioned, I actually didn't have time to take flats with this one. So if I did, you would simply import them the exact same way that you imported the darks or the bias frames. Let's go ahead and hit this recommended settings button and see what's inside of here. The way this works is these are kind of like toggle switches. If it's blue, that means that that option is not enabled. If you click on it, it will enable it and it will turn it green. So here you can see I've got this option enabled. To be perfectly honest with you, I have kind of played with each of these settings just to kind of see what effects I get. And most of the time I kind of just leave them as you see here, but I will make a couple of notes, especially with this one right here, the super pixel mode. I hate super pixel mode. I don't know what it's supposed to do, but it jammed me up and created a lot of problems and wasted a lot of my time. So let me show you what it was doing for me. I don't know if I was doing something wrong or what, but I'm just gonna pop into Photoshop here really quick. So here we have a picture of it's actually the same target we're working with, the Eagle Nebula, but this one was shot with my old telescope. And I want to show you what the super pixel mode was doing. When it would stack the picture, it was actually cropping this into the upper left-hand corner like this. So when my stacked image came out, this is all I was getting. It was cropping out like the entire rest of my target. So I don't know why it was doing that or what that feature is supposed to do, but I was not having good success with it. So I leave that option disabled. Scrolling down a little ways here, we've got some options for how to do these clipping things. I actually don't have any idea what these options do. I leave them set to the default settings and I seem to get good results. I will sometimes toggle between these different options. I usually use this option here, the RGB background calibration, and it works most of the time. But every now and then when I'm editing my picture, you want to have a nice dark sky in the background. And so as you're stretching your image, I find that sometimes the stacked image, the sky is too gray. Sometimes I can fix that, but sometimes it's just being really difficult and I can't get rid of the gray. So if that's the case, I'll switch to that per channel background calibration instead, and it will help take out some of that gray stuff in the sky. But here we're going to use RGB background calibration for this one, and if it doesn't look good, then we'll change it. So all of these settings look good, and we're going to press OK. Now we're going to use these stacking parameters. We'll just step you through all of the tabs here, give you a quick rundown on what's going on here. When the computer stacks the image, it's going to, some of your pictures might be kind of wonky over here and some other ones might be wonky in another way. And so the question is, what is your final image going to look at if things aren't quite overlapping perfectly? So in standard mode, that's the option that I use most of the time. What it's going to do is kind of create like an average of all of your images stacked on top of each other. So it's going to create the largest image possible with as much data possible, but you will have some little areas that might be a little bit light on data. If we were to switch to mosaic mode, you would see that it was going to create the largest possible image given whatever pictures you have. And so there might be straight up missing data in some of those areas. In intersection mode, it's only going to create a stacked image where you have all of your images overlapping. So anything where a little bit of this one is outside, that's going to get excluded. So I get good results from standard mode. We're going to go ahead and use that. Now I recently have discovered this drizzle feature. This is a magical thing. Let's talk about that for a moment. So what is this 2x drizzle? So it turns out this is actually some NASA technology that they developed for the Hubble Space Telescope. And we get to use it as civilians, so that's pretty cool whenever you can use NASA technology at home. What's going on here is it's going to upscale your image. And now, picture this. Let's say that you take a picture of someone's face. You know that if you take that picture and stretch it out larger, it's going to get pixelated and fuzzy. But if you were to take that same picture and make it smaller, it actually gets sharper. So it's going to use some NASA technology to upscale your image without really making it blurry. And then what you can then do is make the image smaller from that point, and you actually end up with a much sharper image than you would had you not drizzled it. So that's pretty cool. Now notice that Deep Sky Stacker has an option for a 3x drizzle if you really want to get crazy. I experimented with both and I got better results with the 2x. So that's the one that I prefer to use. If I go to the light frames, I usually just keep this on average. I don't even know what these other options do. I kind of played with all of them and I got the best results from average. And same thing with dark and bias. These were the, I believe, the default settings, so I just left them set to median and median both. Alignment, I usually use this as automatic. The only time I've ever had to use like no alignment is when I'm using a I did a project one time where I had some foreground elements that were messing with my stacking, and so I had to use no alignment for that, but I always use automatic. Intermediate files, I never do anything in here. Those are just the default settings. Cosmetic, I did enable this feature. I get pretty good results with this. I noticed that my camera was giving me some hot pixels, and this little checkbox does a really good job of detecting and removing those hot pixels. So I like to have that feature enabled. And then output, I don't believe I did anything in here either. So those are all the default settings, and I press OK. All right, we are ready to go. So we're going to click the OK button, and what we're going to see is a summary of what we're doing. Now, I like this page because this is where it's going to tell me the total integration time. So here I've got 19 minutes and 0 seconds worth of narrowband images I'm going to be stacking. Let's go ahead and hit the OK button, and the computer is now going to stack our images. This process could take a little while, especially when you enable 2x drizzle. That really slows it down because it's doing all that upscaling. So I'm going to fast forward through this part and let it do its thing. All right, Deep Sky Stacker has finished stacking our image, and we see we've got our result here on the screen. So don't really worry about what this looks like. Don't worry about messing with the histogram or any of this stuff down here at the bottom. We're going to just save this image and then bring it into Photoshop for editing. But before we do, we still need to stack our wideband filter as well. So let's do that next. Now the first thing we need to do is save this image. So let's go ahead and click on this button right here, Save Picture to File, and put it in a place where you know where it's going to be. What I'll usually do is create a folder for my project, and I'll save my image in here. This is my narrowband stack, so I'll call it narrowband stacked and save that there. Now there's one more thing I want to do before I leave here and stack the other filter. I want to create a star mask. I'll show you what to do with that later on. So here I'm just going to press the Create a Star Mask button. I don't know what any of these options do. I just leave them all set to their default, and I press OK. I'm going to save this as narrowband star mask, saving it to the same project folder where I saved my stacked image. All right, time to import our wideband images. I'm going to press this option to clear the list. This says, do you want to save any of this stuff? Nah. All right, so basically we're starting over. We're going to do all the same stuff again for our other filter. So I'm going to do it a little bit faster this time since you know the process. We're going to open the picture files. This time I'm going to bring in my wideband images. And I'm also going to bring in that reference image as well. Remember, the reference image is the key to making this work. We have to use the same reference image for our narrowband as we did for our wideband. So I'm just going to bring them all in. I'm going to check them all, but then I'm going to go through and uncheck the reference image. We don't want to include it in the stack. We only want to use it for stacking purposes to align those stars. I'm going to bring in my dark files just like we did before, making sure that I'm using the same exposure and gain that I did for my target. So 60 seconds, 120 gain, bringing in the darks, bringing in the flat files if I had them, but I don't have any for this set. Going to bring in my bias files. Again, these ones have to be set to the same gain as my light files, and that is 120 for these as well. Bringing them in. There we go. We have all of our lights, all of our darks, and all of our bias. We should have some flats too, but I don't have them for this. And here I have unchecked my reference image. Time to stack. Let's click the Register Checked Pictures button, just like before. Very quickly this time, just going to go to Advanced and hit the button to see how many stars we've got. 1,297. I told you my wideband filter does a much better job of pulling in those stars. That's why we used it as the reference image. Coming over here, I have already gone through and deleted the pictures I thought were not good. So I'm going to tell it to use 100% of the images in this stack. if you didn't take the time to check your pictures, you could set this down to like 80%, and that way it'll get rid of 20 of your worst pictures. Recommended settings, just like before, I'll just go through this to see if there's anything that I need to change. I usually leave it to all the default settings that we just talked about. Stacking parameters, just go through one more time, make sure that enable 2x drizzle is checked. Using the standard mode for my stacking, and my alignment is set to automatic. Those are really the only features that I only ever really look at, and we'll press OK. And we're done. So let's press the OK button to lock in those changes. Here is my summary. I had a lot of satellites passing through my image when I was doing the wideband, so I ended up deleting about 3/4 of my pictures were lost to, I don't know, I'm going to blame it on Starlink. 8 minutes is all I got of my wideband. So maybe we'll revisit this target in the future. 8 minutes of wideband images, press OK. It's going to stack, drizzle, do its thing. Now the stack is complete, and this image looks quite gray, like we were talking about before. It looks like it's kind of blown out a little bit. I'm not sure if I'm going to like this one or not. So what I'm going to do is I'm going to restack this one more time, and I'm going to use that other option that we talked about and see if perhaps I get a better result. So it's a little bit of trial and error with a lot of these settings. So let's do it one more time and see what it looks like. But before I leave here, just in case this ends up being the better of the two options, I do want to save it so I don't have to wait for it to restack all those things a third time. I'm going to save the picture file, and this is going to be my wideband stacked. And we're going to click on save to save that image. And while I'm at it, I'm going to create a star mask as well. I leave all those settings set that way and just press OK. We're going to call this the wideband star mask. Save it. So I'm going to restack this again using a different option to see if we get a little bit more contrast here. So I'm just going to click on Register Stacked Pictures one more time, go back into Recommended Settings and scroll all the way to the bottom. And this is where we're going to use this other option. If resulting images look too gray, then try per channel background instead. So we were using the RGB background. Let's switch it to per channel and see if that makes any difference. Press OK. Everything else will be the same. Press OK again. Still doing 8 minutes, but we're using that other stacking setting. So we'll press OK and let it do its thing. This time the image looks a little bit on the green side. I'm not sure which one I'm going to like better, so I'm just going to go ahead and save them both. Once I get them into Photoshop and start stretching them, we'll be able to choose which one we like best. So just like before, we're going to save this. Okay, we're going to save this. We're going to call it the wideband stacked, and we use the per channel option on this one. So I'll just take a note to remind me what I did here. Save that. And we'll save a star mask for this one as well. Star mask, wideband, per channel. Now that we have completed all of our stacking, we can bring these our stacked images into Photoshop. I'll go ahead and just start with the narrowband stacked TIFF. Now again, I'm going to be making a special video just about the Photoshop side of things, but I did want to show you one quick thing. When you bring your images into here, they are going to look quite a bit darker than they did in Deep Sky Stacker, but that's why we need to stretch them. Once we complete that process, this will be nice and bright. So if this is the first time that you're doing something like this, don't get discouraged at this point. That's what happened to me. I thought that there was something wrong with my equipment or something was going on because my images were so dark and I didn't understand how stretching works. So I actually went in through like the Camera Raw filter or brought this into Lightroom or something and just tried adjusting the exposure, and that does not work. It yields very poor results. So if you want to make sure that you catch that video on editing in Photoshop, make sure to hit the bell and subscribe. Also, if you could like or leave a comment, all forms of user interaction help the channel. Thanks for watching.